Good afternoon. So now we have an equation here and we have to solve it geometrically. So what do? Well, first we have to talk about the information we're given. We're told that these two expressions are equal to each other. So if these two expressions are equal to each other, then we can assume that they must equal the same output. And that variable represented, the output would be y. Okay? If that's the case, then we can rewrite these two expressions as two separate equations, understanding that they are set equal to each other. Because they are set equal to each other, that means their output would be represented by the same variable, y. So we are going to rewrite it, and I'm going to choose two different colors so you can see the difference. Y equals 3x minus 7. Second expression, we're going to rewrite it as the equation y equals 2x plus 1. And notice that, yes, y and y are different colors, but they still represent the same outcome. Because they represent the same outcome, then we can say these two expressions are equal to each other, which we got here. Okay? So now we take this information and we put it in our graphing utility. In this case, it will be Desmos. All right, so if I click on here, here are my two equations. Y equals 2x plus 1, y equals 3x minus 7. And we notice that on the graph, they do intersect. They intersect at 817. So what does this mean? It means that the only value for x is 8 that will work for these two equations. And the same output, which we talked earlier, is 17. So in a nutshell, what we look for is when we graph these two equations, we're looking to see if they intersect, and if so, where, because that is the solution to the problem. On the next video, we'll do a couple of weird ones, be pretty fast. We'll do both algebraically and geometrically, and then we'll summarize and how those two work. Until the next time.